So, welcome to this second tutorial session on the topic of a smart grid and basics to advanced technologies. It is taken by me, Mohd, the Prime Minister Research Fellow at the Department of Electrical Engineering. And this is the second session on this 6th August 2024. So, let's start with the new topic. Before in this tutorial session, I will be solving questions, assignment problems. Before that, I will do a recap of what you have learned in the last week. Okay. So now I will recap it. Just before that, wait a second. Okay. Yes. Now, in the last week, you should have gone through a topic like advanced metering, infrastructure, which is generally known as AMI. If it is visible to you, if not, then please write it down in a chat. I will see. If it is okay, then press yes or whatever you. It is visible to all of you. My handwriting. Okay. Sure. So this is the topic you must have gone through the video lecture. So actually what it is AMI? It is an advanced metering infrastructure which refers it refers to connecting smart meters, meter data management and elements supporting the communication between the smart meters and the data management. So it is generally refers to connecting what it connects. It connects smart meters, meter data management and other elements of communications elements which support the communication. Okay. So actually it allows, what does it allow? It allows meters to read by the utility personal over wireless link. So it enables what it does enables, it enables the utility to read meters. Okay. It also helps in it also helps and it can be done wirelessly. So it also reduces the billing cost or infrastructure use or the personal use for electricity billing. So actually what it does here, the smart meters. So this is this is like the block diagram must be like this. This is AMI. These are generally the discoms utility and these are the consumers which have smart meters installed in their homes or premises. So this is how what it does. It connects the utility to the consumer, but through which the utility can read the meter data, and it also helps what it does. It also helps the reduction in cost associated with the meter reading. So next topic in this is what is smart meters? You must have heard about it. Smart meters. Okay. You must have heard about these smart meters. Just a second. Okay. So what are these smart meters? They actually measure different values. And what it does, it generally refers to the periodic measurement. Sometimes they measure after 15 minutes or after every 5 minutes or maybe after every hour. What it does, what they measure RMS voltage, they measure RMS current and also
energy
energy
consumption,
consumption,
phase angle of the measurement,
measurement,
instantaneous
instantaneous
value,
value,
reactive
reactive
power,
power,
or
or sorry,
instantaneous
instantaneous
active
active
power,
power,
instantaneous
instantaneous
active
active
power,
power,
also
also
power
power
factors.
factors.
They
They
also
also
measure
measure
power
power
factors.
factors.
So
So
these
these
type
type
of
of
the
the
functions
functions
is
is
generally
generally
provided
provided
by
by
a
a
smart
smart
meters.
meters.
Okay.
Okay.
So
So
this
this
is
is
generally
generally
a
a
recap
recap
of
of
what
what
you
you
have
have
learned
learned
over
over
the
the
last
last
week.
week.
Okay.
Okay.
So
So
what
what
happens
happens
here
here
is
is
this:
this:
each
each
meter
meter
communicate
communicate
with
with
the
the
MDMS
MDMS
over,
over,
like
like
this
this
is
is
a
a
meter.
meter.
It
It
communicates
communicates
to
to
which?
which?
It
It's
communicates
communicate
to
to
MDMS,
MDMS,
which
which
is
is
meter
meter
data
data
management
management
system
system
over a
over a
communication
communication
panel.
panel.
ठीक है?
ठीक है?
Okay.
Okay.
तो
तो
इससे
इससे
क्या
क्या
होता
होता
है?
है?
And
And
these
these
are
are
generally
generally
end to
end to
end
end
encrypted
encrypted
like
like
internet
internet
protocol.
protocol.
In the
In the
last
last
week
week, we have
actually we have
solved
solved
the
a question
question
regarding
regarding
this.
this.
The,
The
what
what
type
type
of
of
communication
communication
protocol
protocol
they
they
use?
use?
They
They
generally
generally
use
use
IP.
IP.
Okay.
Okay.
And
And
each
each
IP,
IP,
each
each
meter
meter
has
has
an
an
IP
IP
which is
which is
addressable
addressable
by
by
a
a
MDMS.
MDMS.
So
So
this is
this is
like
like
this.
this.
Now
Now
what
what
happens
happens
here
here
is
is
this:
this:
there
there
are
are
actually
actually
smart
smart
meters,
meters
and they
and
are
they are
generally
generally
connected
connected
to
to
a
a
wide
wide
area
area
network.
network.
Okay.
Okay.
So
So
this
this
is
is
like
like
the
the
this is
this is
how
how
the
the
advanced
advanced
metering,
metering,
or
or
we
we
can
can
say
say
smart
smart
meters,
meters
generally
generally
send
send
their
their
data.
data.
Okay.
Okay.
Now
Now
what
what
happens
happens
here
here
is
is
this:
this:
in
in
order
order
to
to
make
make
the
the
system
system
an
an
automation
automation
based.
based.
Automation
Automation
based
based
means,
means,
so
so
a
a
distributed
distributed
system
system has to
automate
automate
itself.
itself.
Sometimes,
Sometimes,
sometimes
sometimes
any
any
error
error
occur,
occur,
any
any
fault
fault
occurs,
occurs,
there
there
must
must
be
be
reclosers
reclosers
over
over
there.
there.
Reclosers
Reclosers
must be
must be
there
there
so
so
that they
that they
can,
can,
isolate a
isolate a
circuit
circuit
which is
which is
faulty.
faulty.
So
So
that's
that's
why
why
there
there
is
is
a
a
term
term
known
known
as
as
distribution
distribution
automation
automation
system.
system.
What
What
it
it
does
does
here
here
is
is
this:
this:
it
it
actually
actually
it
it
actually
actually
has
has
a
a
the different
different
subparts.
subparts,
Like
like
one
one
subpart of
subpart
the
of the
distribution
distribution
at
at
automation
automation
is
is
recloser.
recloser.
What does
What
the
does a
recloser
recloser
does?
does?
It
It
monitors
monitors
and
and
breaks
breaks
the
the
breaks
breaks
the
the
feeder
feeder
circuit.
circuit.
If any, if
If
the
the
current
current
passes
passes
through
through
the
the
threshold
threshold
value.
value.
Okay.
Okay.
If a
If a
current
current
passes
passes
through
through
the
the
threshold
threshold
value,
value,
it
it
what
what
it
it
does,
does,
it breaks
breaks
the
the
feeder
feeder
current,
current,
and
and
after
after
a
a
short
short
time,
time,
when
when
the
the
current
current
value
value
goes
goes
beyond the
beyond the
threshold
threshold
value,
value,
it
it
reconnects
reconnects
the
the
feeder
feeder
circuit.
circuit.
Okay.
Okay.
This
This
is
is
how
how
the
a
reclosure
reclosure
works.
works.
And
And
there are
there are
another
another
component
component
of the
of the
distribution
distribution
automation
automation
system
system
is
is
what
what
it
it
is?
is.
It
It
is
is
switches.
switches.
Actually,
Actually,
switches
switches
are
are
done
done
to,
to
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 sectionalize,
sectionalize,
to
to
isolate
isolate
a
a
faulty
faulty
section of
section
the
of the
feeder
feeder
circuit.
circuit.
So
So
these
these
are
are
done
done
deployed,
deployed,
generally
generally
deployed
deployed
to
to
sectionalize
sectionalize
the
the
faulty
faulty
sections
sections
of
of
the
the
feeder.
feeder.
Actually,
Actually,
and
and
these
these
are
are
generally
generally
operated
operated
manually,
manually,
or
or and
they
they
are,
are
and they
they
can
can
also
also
be,
be
operated
operated
by
by
a
a
remote
remote
command
command
through a
through a
remote
remote
terminal
terminal
unit,
unit
RTU.
(RTU).
Okay,
Okay,
by
by
using
using
this
this
terminal
terminal
unit,
unit,
these
these
switches
switches
can
can
be
be
made to
made to
turn
turn
off
off
and
and
on.
off.
Okay,
Okay,
now
now
what
what
are
are
the
the
operations
operations
according to
according to
this
this
distribution
distribution
or
or
automation
automation
system
system
does?
does? Each
Each
of
of
the
the devices
devices
must
must
includes
includes
ID to
ID to
support the
support the
required
required
measurement.
measurement.
So
So
what it
what it
does?
does?
First
First
operation
operation
is
is
this:
this:
it
it
must
must
include
include
IDs
IDs
to
to
support the
support the
intelligent
intelligent
devices
devices
to
to
support the
support the
measurement,
measurement,
monitoring,
monitoring,
and
and
the
the
control
control
function.
function.
What
What
happens
happens
here
here
is
is
this:
this:
these
these
IDs
IDs
communicate
communicate
with
with
a
a distribution automation control center control system, which is also known as DA master control. Okay. And every communication, every command is sent by the DA master to individual IDs through the concentrator. Okay, this is how a distribution control system is done. In these, for as we know, there are various monitoring measurement devices are available. SCADA is there, and phase measurement, PMU based, phase measurement units can be deployed. Actually, phase PMU has a slight edge over SCADA because the data which is measured through PMU has a good quality. Okay, over a SCADA. Okay. That's why generally, but problem is that the PMU is a very costlier thing, and it cannot be installed everywhere. So that's why generally people use SCADA base. So what does SCADA refers to? It refers to supervisory control and the data acquisition. Supervisory control and the data acquisition. Okay. It does signifies that, and it is actually a system which collect the data from various sensors which are installed at a plant or any remote locations. And what it does here, after collecting the data, it sends to the central control system, central computer system, or we can say. Which then what does that central computer system does? It manages and controls the data, and the component of the SCADA are generally, first component is the master station, which is another is the RTUs, which is remote terminal units. Remote terminal units. And third is the communication, because the communication system will be used by SCADA to transfer the data from the sensor to the master station. Okay. These are the component, and the master station, what it does, the data which is collected from the sensors are sent toward this master data, where there any human is there, which will analyze the data sent by the SCADA. That interface is known as HMI, means human machine interface. And it will be in the control center. Okay. So, and there may be more than one control centers. Okay. So generally what happens here is this, after this, another term which I wrote over here is remote terminal unit. Actually it is a microprocessor based device. It is a microprocessor based device which interfaces an SCADA system, by transmitting the data to the master station and changing the state of the devices by receiving the control messages. What it does here, let's say this is a master station, and these are RTUs, and there will be more than one RTU. So they generally transfer the data from the here. These are the sensors, you can say. So they will transfer the data to the master station, and on that data master station, what it will take a decision, and that decision in the field will be transmitted through the RTUs. Now coming towards the another thing is Okay.
Now,
Now,
in
in
this
this
here,
here,
there
there
is
is
another
another
thing
thing
in the
in the
smart
smart
metering,
metering,
which
which
is the
is the
signal
signal
acquisition.
acquisition.
This is
This
the
is a
very
very
important thing.
important thing.
How
How
to
to
how the
how the
signal
signal
is
is
acquired
acquired
in
in
a
a
master
master
signal.
signal.
So
So
whatever
whatever
is
is
this,
this,
the
the
fundamental
fundamental
electrical
electrical
parameters
parameters
which
which
are
are
required
required
for
for
this
this
are
are
the
the
frequency
frequency
of
of
the
the
voltage
voltage
and
and
the
the
magnitude
magnitude
and the
and the
phase
phase
displacement
displacement
relative to
relative to
the
the
voltage of
voltage
a
of a
current.
current.
So
So
what are
what
the
are the
data
data
required?
required?
The
The
magnitude
magnitude
and the
and the
frequency
frequency
of the
of the
voltage
voltage
and
and
the
the
phase
phase
displacement.
displacement.
Phase
Phase
displacement
displacement
of
of
current.
current.
This
This
is
is
the
the
this
this
is
is
required
required
over
over
here.
here.
And
And
other
other
also
also
parameters
parameters
like
like
PhDs,
PhDs,
power,
power,
these
these
are
are
also
also
used.
used.
Now,
Now,
for
for
sensing
sensing
the
the
current,
current,
CTs
CTs
are
are
used,
used,
which are
which are
used as
used
a
as a
measuring
measuring
instrument,
instrument,
measuring
measuring
instrument in
instrument
the
in the
signal
signal
acquisition.
acquisition.
So,
So,
CTs
CTs
are
are
generally
generally
used
used
for
for
sensing
sensing
the
the
current,
current,
and
and
the
the
disadvantage
disadvantage
of
of
these
these
CTs
CTs
is
is
that
that
they
they
have a
have a
non-linear
non-linear
response
response
of the
of the
CTs,
CTs,
can
can
cause
cause
management
management
or
or
energy
energy
errors.
errors.
That's
That's
why
why
you
you
have
have
heard
heard
about
about
in
in
your
your
instrumentation
instrumentation
classes
classes
there is
there is
CT
CT
error.
error.
You
You
have
have
calculated the
calculated the
error.
error.
So
So
why
why
those
those
error
error
occur?
occur?
Due to
Due
the
to the
non-linear
non-linear
response of
response
the
of the
CTs.
CTs.
Okay.
Okay.
Now
Now
after
after
this,
this,
now
now
after
after
this,
this,
we
we
will.
will.
I
I
assume
assume
that
that
you
you
have
have
learned
learned
this.
this.
Okay.
Okay.
Now
Now
after
after
this,
this,
we
we
will
will
come
come
towards
towards
the
the
distributed
distributed
energy
energy
resources.
resources.
What are
What
the
are the
distributed
distributed
energy
energy
resources?
resources?
So,
So,
so actually
actually
there
there
are
are
in
in
your
your
course
course
there
there
are
are
two
two
types
types
of
of
distributed
distributed
energy
energy
resources which are
resources which are
discussed.
discussed.
First
First
is
is
solar
solar
and
and
wind,
wind,
and
and
these
these
are
are
very
very
much
much
important nowadays.
nowadays.
Okay.
Okay.
So
So
what
what
happens
happens
here
here
is
is
this:
this:
we
we
will
will
first
first
discuss
discuss
how
how
the
the
hello.
hello.
Yes, sir.
Yeah,
This
yeah,
is
yeah, sure.
Preeti here.
Yeah,
Yeah,
I had a doubt, sir.
yeah,
yeah,
Uh,
sure.
sure.
yes, sir. So, if we are segregating the distribution sector into one is the consumer side and
Yeah,
another
Yeah,
is the maintenance of distribution system side. So, the
and another
another
is
is
the
advanced
the
metering infrastructure,
yeah,
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 another is the maintenance, grid maintenance side, sir.
yeah,
yeah,
yeah.
yeah.
Okay, so
Okay.
Okay.
I just wanted to confirm, sir, the smart meters and advanced metering infrastructure, it
Uh-huh.
comes in the customer side, and in the
Yes.
Yes.
maintenance side, the RTU and SCADA system, they
Actually,
Actually,
what it
what it
does
come
does
under
here,
here,
the
mhm,
maintenance.
yes,
actually
actually,
what it
what it
does
does
here,
here,
advanced
advanced
metering
metering
systems
systems
are
are
generally
generally
installed,
installed,
are
are
generally
generally
applied
applied
for
for
the
the
smart
smart
meters.
meters.
Okay,
Okay,
because in
because
a
in a
smart
smart
meter
meter
they
they
are
are
connected
connected
through the
through
internet,
internet,
through
through
IP
IP
protocol,
protocol,
and
due to
Bluetooth
the
connection.
connection,
We
we
can
can
calculate
calculate
the.
the.
I
I
have
have
already
already
in
in
initial
initial
slide
slide
we
we
can
can
calculate
calculate
the
the
energy
energy
data,
data,
or
or
we
we
can
can
calculate
calculate
the
the
automatic
automatic
AMR,
AMR,
automatic
automatic
meter
meter
readings.
readings.
Okay.
Okay,
So
so
what
what
happens
happens
here
here
is
is
this.
this:
This is
this
the
is the
part
part
for
for
the
the
smart
smart
metering,
metering,
advanced
advanced
metering
metering
infrastructure.
infrastructure.
Now,
Now,
next
next
thing
thing
which I
which I
discuss
discuss
about
about
there
here
is
is
this
this
the
the
distribution
distribution
automation
automation
system.
system.
Actually,
Actually,
what
what
happen
happen
here
here
in
in
a
a
smart
smart
grid,
grid,
everything is
everything is
automated,
automated,
where the
where the
automation of
automation of
all
all
functions
functions
are
are
done.
done.
What
What
happen
happen
here,
here,
and
and
that
that
can be
can be
automated
automated
by
by
the
the
by
by
getting the
getting the
information
information
from the
from the
field,
field,
like
like
from
from
the
the
substation
substation
devices,
devices,
with the
with the
devices,
devices,
measurement
measurement
devices
devices
deployed on
deployed
the
on the
feeders,
feeders,
meters
meters
deployed at
deployed
the
at the
consumer
consumer
location.
location.
The
The
distribution
distribution
automation
automation
comes
comes
cover
cover
all
all
these.
these.
So
So
in
in
that
that
distribution
distribution
automation
automation
system,
system,
there is
there is
a
a
thing
thing
called
called
SCADA
SCADA
system.
system.
What
What
it
it
does
does
here,
here,
it
it
actually
actually
monitors
monitors
and
and
controls the
controls the
distribution
distribution
substation.
substation.
Okay, and what it does here, how the SCADA how SCADA collect the data. There are three component of that. First is the master station, and there is RTU, remote terminal unit, because the sensors will be placed in the field. But those sensors are very far away from their master station. And what happened here is that all these sensors, there will be thousands of these sensors. All these sensors through an RTUs send the data at every hour, after every 5 minutes, or whatever it is the time they have set, to the master station. Now, at this master station, there will be a human interference which will monitor all these data. Based on the data, if there is any outage, if there is any contingency thing we have to be done, he will send the command from this RTU to the sensor, and the sensor will work according to that. Okay? I might be clear about this.
Yes, sir. Sir, but by sensor, do you mean the IEDs?
Yeah.
Because, sir, what I know, sir, the signals from the current transformer and potential transformer is taken for current and voltage measurement.
Yeah.
So, are these IEDs placed with the CT and PT, sir?
Actually, IDs, intelligent devices connect. In a way, they are placed to do those locations also. Okay. In a way, we can say that, but they are But what the distribution automation does, it has the intelligent devices to support the measurement, monitoring, all these control function. And these IDs, they communicate with the distribution control system based on their data, and collect, and the, what a DA control system collect the data from IDs from one or more feeders, and then it forward the data toward the master. And based on the data, the operator will take a decision, whatever the contingency he need. If there is normal operation, there is no need to anything do that. Okay.
So, IDs cannot directly communicate with the master station?
IDs, no. A data concentrator will collect the data from ID, which are installed on one or more feeder, and forward the data toward the data master. Okay.
And the nature of the data is, it is analog or digital data, sir?
It is generally digitalized. In a smart metering, it is generally digital. Okay.
So the digitization, the analog to digital conversion, it's happening in the IEDs or the RTUs, sir?
Actually, it will be it will be doing at the data concentrator, where the data has been taken up, and it will be doing at the master station. At that point, the digitalization of the data, because as a human you cannot analyze the analog, because there will be a software in which the data will be going on, and it will show the trend, whatever the trend over there is there. So if there is any outages based on that analysis, so it will, the operator will can control those things. Okay.
Okay, sir.
Okay. So now next part in the smart grid is what? Just a second. Okay. Now the next part in this here is what it is here is the distributed energy resources. Now, in the distributed energy resources, as per our syllabus, there are two types of distribution energy resources. First is the solar, and another is the wind. And these are two, a clean energy sources generally, as a clean energy sources. Now, what happened here is that that these are easy to install. In comparison to hydro or any nuclear based. Okay. And they can also be used for meeting the peak demand. Okay. So this is how. Just a second. Okay. Now,
Now,
what
what
happens
happens
here
here
is
is
this.
this. They are actually the distributed energy resources. They are generally connected to the distribution provider electric system at the around primary voltage, which is less than 100 kV, and or secondary voltage, which is less than I think it is around 1 kV actually. Okay. At these junction point, these are generally connected. Now coming to the solar and wind generation in the in Indian sector. You can see for the last 20 years, 20 to 23 years, there is a significant increase in the solar and the wind generation, and it is measured in megawatt. It is around 197. Like this, you can see it is clearly now. This graph actually shows the variation of electricity generation from solar and wind compared to the coal. And you can see the coal is here, but slowly and slowly, solar and wind generation are trying to increase their generation and replacing the coal. Now, this is actually the recent trend of small hydro, wind, biopower, and solar. As you can see that in this, the solar has the highest generation in all the distributed energy resources. Wind has up to it is like here it is 42633 megawatt. Biopower is here 1080 to 0.04, and small hydro is over here. So you can clearly see from here that solar and the wind are the major distributed energy resources. So this is regarding the distributed. And now coming toward this, there are in the residential sectors, what it does, there are solar photovoltaic, natural gas fired fuel cells, and there will be small wind turbine. And for a commercial industrial sectors, the energy can be supplied by hydropower, wind turbines. These are actually large wind turbines, solar photovoltaic cell, and they are known as combined heat and power system and biomass combustion. Now this is the installed solar capacity, and you can clearly see that India has the second largest solar capacity has been installed. And now coming to the solar cell, what are the solar cells are? Actually, solar cells are the photovoltaic devices that convert the light energy into electrical energy, and energy based on the principles of the photovoltaic effect. Actually, the photovoltaic effect is the basis of the conversion of the light to electricity, and it is light which is a pure form enters the PV cell and impart enough energy to some electron to free them. So this is like this is how. Actually, you would have already seen this, the phenomena of the solar PV cell in your, I must be say 11th and 12th classes. But here I will recap this. This is an N-type silicon. When light energy comes over here, it generates an electron hole pair, and due to the generation of the electron hole pair, there is a potential barrier is created over here, which creates the voltage, which drives the current through the circuit. And if we complete this circuit for an external load, a current will be flowing over this. Now, what are the advantages of the solar cell? The first of the advantages is it can be used as either the distributed power generation, and another is that the solar PV has no moving part, so there will be no mechanical losses, and it is abundantly available in our energy in our solar system, and is energy independence and environmental compatible fuel, which is a sunlight is free and does not cause any pollution. And it has a maintenance cost, but it is very minimal and have a very long service lifetime. But there are several disadvantages. First is that the waste generated from the solar cell cannot be, till now, right now, there is nothing on the research part which can, use that waste which is generated from the solar cell, because solar cell lifetime is 25 years. So after some 25 years, or we can say 15 years, that solar panel
will be treated as a waste. So how to use that waste? It is a burning research topic. Now, another thing is that the most actually the to install the solar PV, we have to need a larger area, a large open area. We can say so. Therefore, surface area requirement is very high, and also because the solar energy is very intermittent. Some days it may be available, some days it may be available, some days it is not. So the power generated is very intermittent. It varies with the time or the day and the season in which you are generating the energy. So it is also depend upon the availability on the sunlight. Now there are various solar cells which has been developed. Right now, the third generation of the solar cell has been used. The first generation solar cell are silicon PV, which are crystalline solar cell. They have the higher carrier mobility, but they are costly, and the energy loss due to photon is very high. And after this, there comes the second generation, which are thin film based, which are amorphous silicon, and these are selenide cell. And right now, there are third generation, which are known as emerging PV, which are perovskite solar cell, organic. In the first, you can see I have written over here this the advantages of the first generation solar cells is that they have the efficiency comparable to 15 to 22%, and they have a low lifespan. Availability is very large because it is generally based on silicon, and it is a very practical choice for mass production. As I said, that there are various disadvantages to this. First is that it involves the production actually process the high temperature and complex process, and which lead to the higher manufacturing costs. It also produces a significant generation waste, and these are fragile in nature and can easily break down during the handling and installation. Then after this comes the second generation solar cell based, thin film solar cell based. These technology uses less material and simpler manufacturing processes. They are lighter in weight and have a better performance in low light. Means whenever there is less sunlight, they will produce a considerable amount of energy in comparison to the silicon cell. But another thing comes to their disadvantage is they have the lower efficiency. It's around 10 to 12%. Lifespan is very short, and they get faster degraded. And after some thin technologies uses toxic materials like cadmium, which are environmental and health concern. So it will what it will does if the environmental and health concerns are increasing. So what it will be why should we are using the solar cell? Because our whole motive here is to reduce the environmental concern. Now after this, the third generation, which is a perovskite based solar cells comes. These category included perovskite solar cell, organic photovoltaic, and dye sensitized. The advantages of these are the potential for high efficiency, and some emerging technologies like perovskite cell have shown higher efficiency, low cost materials for versatile applications. They are flexible, lightweight, and semi-transparent, allowing for a wider range of applications. Another, with every technology there comes advantages, there comes disadvantages, and based on the disadvantages, researchers work and try to reduce the disadvantages. So the disadvantage of the third generation is still the stability, the durability, and scalability. While scaling up the industrial level is very challenging. And there are some environmental and toxic effects always there with any technology. So these are the some of the generations which are of the solar cell. So now comes the types of PV technology. This is I have already discussed. Now coming to the next. Now, this is a cell operation of a PV cell. What it does, this is energy source comes over the solar panel. Energy conversion happens. and there are this energy inversion and conditioning is the actually power electronic circuit.
What it does here, if we have to store in the we will do AC DC transformation and all the signal conditioning will be done over here. If we have to use it instantly, then it has to convert it into AC and will be used for energy use. If we have to store it in the battery, then it will go toward the battery use and will be used later on. Okay. Now there are two systems. Actually, one is the grid connected solar PVs and another is the off grid.
So what's the difference between an off grid and a solar based and the grid is this? In the grid connected system, the solar cell are installed at any house or whatever the place here, and there is actually what happens here is the energy is generated,
and after
the energy is generated, this energy can be used at the home, and rest of the energy can be transmitted through substation to the power grid. Okay. This is the benefit of the grid connected solar PV system. But it is very complex reason due to increase in power electronic circuitry. But in the off grid, what happens here is that a PV array will be here and it will generate the energy and it will use store the energy in the battery bank and it will be used at the location where the solar PV is installed. It is not connected to the grid. If there is an excess energy, it will be there in the battery bank, but it cannot be transmitted to the grid. So this is the major stark difference between an off-grid and an grid-connected solar PV. These are the solar charge controllers. Actually, what happens here is this, because we have these are done to prevent the battery overcharge. These are also done to block the reverse current and prevent the over discharge from some batteries and some model and prevent the electrical load and display the better battery status. Now coming towards these are the tabularized differences. A grid connected in a building where have two power supplies, one from solar PV and the other from the grid. The combined load will be connected to the AC distribution board, and if the solar PV exceeds the demand, excess electricity, as I said, can be exported back to the grid. If there is no electricity, the power grid can also supply the whole demand. Okay, now off-grid solar PV system is this. These are applicable generally for the areas without power grid. Currently, such solar systems are used, such PV systems are used at isolated place where there is no grid connection, and it can also be used within the cities, because what happens here is this. Sometimes there will be a higher number of outages. So what happens here is this: home can use this solar PV system to reduce the dependency. Now coming toward the types of solar, this is same like this. Just a second. Just a second.
Now coming to this.
Now coming to the solar photovoltaic array modeling. This is the equivalent circuit of a PV cell. This is the diode. This is the equivalent circuit of the practical diode, and a series resistance is connected, and a shunt resistance is connected, and this is the output where the generated voltage will be there. Its conversion efficiency is 10 to 17%. PV array costs around 57% of the total cost, and the battery storage system generally costs around 20 to 30%. Now, why we use the shunt resistance? Because significant power losses caused by the presence of the shunt resistance due to manufacturing effect, and that's why it is used. Another is the series resistance. The series resistance in solar has three causes. First one is the movement of the current through the emitter and the base of the solar cell, and also the resistance of the top and rear metal. What it does, the main impact of the series resistance, it reduces the fill factor. Although the excessively high current values may also reduce the short circuit current. I will explain it in a question. There will be a question about why the series resistance is used in your assignments. Now, this is the I. This is I is equal to, if we apply Kirchhoff's KCL over here, what it will be? I is equal to IL minus ID minus ISH. Okay. IL, this is the current. Diode current, we already know the diode equation. Diode equation is this. This one is the diode equation, where eta is the diode ideality factor. VT, we already know this is 25 millivolt, which is actually this is 25 millivolt, and ID is the ISH is the diode current, and IL it is the photo generated current. This is how we calculate the current generated in a solar photovoltaic here. Now coming towards this for now next is the this is the current cell. This equation actually the current voltage relation of a simplified cell is ICL is equal to IL minus this I exponential like this. Now coming towards the most important thing is the IV curve at 25 degree. How the output current, which is I, vary as the temperature, or we can say as the radiation irradiance decreases or increases. You can see clearly the first one is the irradiance at 1000 watt per meter square. As you can see, the irradiance increases, it goes to 1800. The output current like this, it goes like this. So what is irradiance? It is actually the measure of the energy density of a sunlight. Now as the irradiance increases, like in 1400, the irradiance will be the output current is 0.15. Now another curve here is the PV curve. So actually, as the irradiance of the sun's energy increases, the output will also increase. This is the well-established fact. So as you can see, at 400 watt per meter square, the output goes up to maximum at 0.15 megawatt. But as the irradiance increases of 1000 watt per meter square, the output power goes around 0.43 megawatt. As you can see that whenever the irradiance will increase, the power generated by the solar cell will always increase. Now this is actually the PV curve of typical array for different irradiances for a different temperature. So for 75 degree 400, this will be like this. So at the different temperature, as you can see of a higher irradiance, the output generated will be greater. But as the solar irradiance and the temperature changes, at the temperature change, the PV curve will always be shifted down. This is the most important thing. As the solar irradiance and temperature changes, PV curve will always shift down, and it will shift down toward the left. You can see here. It is shift down, and it is shifting down towards the left. Now coming toward the next thing, which is the wind energy. Now, before I explain about the wind energy, there is the share of electricity production from the wind energy for various countries, like United Kingdom has highest, after that Australia, then United States, then after that India. This is the share of electricity. Now, why wind energy is, a very increasing popular source of energy? It for a various environmental benefit. First, it will reduce the greenhouse emission because it does not generally produce any significant emissions for the production of the energy, and also help mitigate the climate change and help in the reduction of the air population. And it is also a renewable resource, meaning it is naturally replenished and inexhaustible on a human time scale, unlike fossil fuels, which are, after a finite time, it will get depleted. It is also a cost effective as if we compare it from, if we compare it with any nuclear or hydro base, the installation of the wind energy is very cost effective, and it also helps to diversification of energy portfolio. Actually, what happened here is this: let's say we have a demand of energy. Okay, this energy demand can be, meet by hydro. There is also nuclear, also from wind, from solar, and actually wind, solar, or thermal base. So what it does, what it does here, ये diversification of the एनर्जी डिमांड कर देता है। कैसे कि हमारी जो एनर्जी डिमांड है सिर्फ एक ही या दो ऑप्शन पे लिमिटेड नहीं है। We have several options. If this option close out, we can meet our demand from solar, nuclear, wind, thermal. If this option closes out, we can meet our demand from other options. So that's why diversification of energy portfolio is very much important nowadays, so that it reduces the dependence on imported fuel and enhancing the energy security of a country. Now, there are various components of a wind energy. There are blades. These are the most important, critical component of the wind turbine. Actually, they capture the wind kinetic energy and convert them into the mechanical energy. And after that mechanical energy can be transformed into electrical energy. And they have different types of designs and structures like shape, airfoil shape. These are designed with an airfoil shape similar to an airplane wings to maximize the lift and minimize the drag of air. And there are another aerodynamic shape that twists and tapers. The blades are twisted and tapered from the root to tip. Actually, this helps in maintaining an optimal angle of attack along the blade length, which generally reduce the bending moment and overall weight. Now, next is the materials which they are formed of. Actually, they are made of fiberglass reinforced polyester because it is most common due to its high strength to weight ratio and cost effective. And another material which they are made are carbon fibers. Epoxy resins are also used to manufacture the blades. Balsa wood and foams are used as the core material in sandwich construction for added stiffness without much weight addition. And now coming to the size and scale. Length of these blades generally varies from 40 to 80 meters in length, and longer the blade it will capture more energy. But problem is that if we increase the length, it will also the risk of structural damages also increases, and transportation because we will manufacture it to the transportation challenge also increases. And the weight of the single blade can range from several tons to over 20 tons depending upon the material and the composition. Now, there is a crucial component of the wind turbine, which is hub, which is served as a central point up to from where the rotor blades are rotated, and all the rotational energy from the wind is transferred to the rest of the turbine by using the hub. And what are the functions of the hub is, it actually, what it does here, it actually connects the blade to the main shaft, and actually it works as an attachment point for the rotor blade and connecting them securely. It also transfers the rotational energy to the main shaft, which then after it transferred to the gearbox and generator. It also controls the blade pitch control, which help in optimizing the energy capture and the protecting the blade turbine from the high winds. Now, there are several components of the hub. First is the blade mounting points, pitch bearing, pitch actuation systems, and main bearing. These actually hubs are generally made up of high strength materials such as cast iron, forged steel, or composite materials. And these metals are generally chosen so that the durability and ability to withstand the significant forces exerted by the rotating blades can be done. Now, the hub is designed to robust and capable of handling dynamic loads, fatigue, and other stresses. It also should not be lightweight, so that it must be lightweight so that there would be no any extra weight on the tower. Now, what happens here is this: when the wind blows, it exerts the forces on the blades, causing them to rotate. And after the rotor blades rotate, they are attached to the hub and causes the hub to rotate along them. And then this rotational energy from hub is transferred to the main shaft, and this main shaft is connected to the gearbox, which increases the rotational speed to a level suitable for a electricity generation. These are the various parts of a turbine, wind turbine, which are brakes, generators, and controller. Generator generally convert the mechanical energy to electrical energy. And what does brake do? There are different types of the brake: mechanical and aerodynamic brake. Like for example, there are extremely high wind and there has to be maintenance done. The brakes are used to stop the wind turbine. And there is a controller which actually controls various parameters like voltage, frequency, and temperature inside the turbine, wind direction, wind speed, and shaft speed. Now, I hope up till now a small recap of what you have learned over the last week should be done, I think. So from now on, I will be solving the assignment question, which is the most important, which is the main task of the tutorial session. Okay. So keep your copy and pen over here, because you have to solve some questions. You have to give me the answers. Okay. Am I audible to you, or you have all left? I think. How many students are there? Hello. What happens? Preeti, Bhargavi, Madhumata, Nandini. Okay, I will solve it no matter what. Okay, if someone try to give answer, it will be better. So the first question here is, what is the function of a DCA in a SCADA? First, acquires the data from the devices, manipulates the data before they are presented to a master, and present the data to the master station. The fourth option is acquire the data from the remote terminal unit. So please answer in a chat the correct option. I will be giving you 1 minute. So the correct option here will be the data collection application acquires the data from the devices with the data communication capabilities via communication port, for example, IDs, like this. Okay. So the next question is, in the context of signal conditioning prior to the input to the ADC stage, dash is applied to the signal. So the options are: first is the feedback signal, second is the high pass filter, third is the low pass filter, and the fourth one is none of these. So please write down in the chat what is the correct option. So the correct option here is this: in context of the signal conditioning, prior to the input to the ADC, a low pass filter is applied. So answer is low pass filter is applied. Okay. So the next question is here: the main impact of a series resistance is 2. Fill in the blanks, the fill factor. So what will be the correct? Here, first in increase, decrease, double or multiply. So please write down in the chat the correct option. For what? Madhumata B? Okay, B. Yes. So the main impact of the series resistance is to reduce the fill factor. Why? Because whenever there is resistance in the circuit, it causes a voltage drop. The voltage drop reduces the voltage available at the load. I will show it later stage how it does. Now the next question is, which of the following PV technologies has the highest efficiency? First is amorphous silicon. Second is copper indium, gallium selenide. Third is monocrystalline silicon. And the next is the polycrystalline silicon. So write in the chat box what is the correct answer. Any one of you? Okay. So amorphous silicon has 5 to 7% of the efficiency, and copper indium has 10 to 13% of efficiency. Monocrystalline silicon has 12.5 to 15% efficiency, and polycrystalline has 11 to 14. So clearly the C option is the correct one. Okay. A PV array. Now this is the question which you have to do some calculation. So bring out your calculator or whatever you use. You have to give the answer. A PV array has the open circuit voltage of 370 volt and a short circuit 28, and a maximum power is 8 kilowatt. Then find the fill factor. I will be giving you 2 to 3 minutes. You write down your answers in the chat box. Just write down your options, whatever option you are getting. Okay. C. Yes. Or next. C. Okay. So whatever here is this, VOC is 370 volt. ISC is 28, and maximum power is 8 kilowatt. So if you put these all in an equation, you will get the form factor, fill factor. What it will be? It will come out to be 0.77. Okay. So C option is the correct one. Now, in the context of a solar cell, as solar irradiance and temperature change, the PV curve shifts. First option, A down to right, B option down to left, C option down to right, and D option up to left. Down to right. Okay. Okay. It is quite clearly, I have already mentioned over here is this. It is what it is, down to left. B option is the correct. Okay. Down to left is the correct one. What I have said over here, it will be, as the temperature and the irradiance changes, this will first, second, now third, fourth. This is output power and this is temperature and irradiance. So it will shift toward left. Like this, it will shift like this. Now, maximum efficiency of a wind turbine is, what does A 69.3, 59.3, 70.3 and 65.3? Write in the chat the correct answer. Okay. The correct answer here is 59.3. The Batt's limit is the theoretical maximum efficiency of a wind turbine conjectured by German physicist Albert Batz in 1920, and he conducted this, and this value comes at 59.3% of the kinetic energy from the wind can use to spin the turbine and generate electricity. Okay. Next question is, why is the low speed shaft connected to a gearbox? First, to increase the stability, B, to increase the RPM, and the third is to decrease the stress, and the D is none of these. So write down in the chat what is the correct option to this. Okay. Anyone else? Anyone else? Anyone else? Ravinder, Madhumata, Vivek. The low shaft is the principal rotating element, and they transfer the torque from the rotor to where it is connected to gearbox to increase the RPM. This is the correct one. Now, during the speeds of extremely high winds and maintenance, which of the below equipment is used to stop the wind turbine for safety of the whole system? First is the low speed shaft, brake, nacelle, D, both B and C. D. Yes. Okay, okay, yes, yes.
It
It
is
is
the
the
correct
correct
one.
one.
Brake
Brake
will
will
be
be
used.
used.
So
So,
during the
during the
periods
periods
of
of
extremely
extremely
high
high
wind,
wind,
maintenance
maintenance
brakes
brakes
are
are
used
used
to
to
stop the
stop the
wind
wind
turbine
turbine
for
for
its
its
safety.
safety.
So
So,
correct
correct
option
option
is
is
the
the
brake.
brake.
Now,
Now,
in
in
doubly
doubly
fed
fed
induction
in
in
DFIG,
DFIG, TEM
TEM
greater
greater
than
than
0,
0,
S
S
is
is
less
less
than
than
0,
0,
then the
then the
mode
mode
of
of
operation
operation
and
and
speed
speed
of the
of the
machine
machine
is
is
what
what
it
it
is.
is.
First,
First,
generator
generator
omega
omega
m
m
greater
greater
than
than
omega
omega
s,
S,
motor
motor
omega
omega
m
m
greater
greater
than
than
omega
omega
s,
S,
generator
generator
omega
omega
m
m
less
less
than
than
omega
omega
s.
S.
So,
So,
doubly
doubly
fed
fed
induction
induction
generator,
generator,
what
what
will
will
be
be
the
the
mode
mode
of
of
operation
operation
of the
of the
machine?
machine?
So,
So,
in
in
this,
this,
the
the
answer
answer
is
is
the
the
motor.
motor.
Omega
Omega
m
m
greater
greater
than
than
omega
omega
s.
S.
This
This
is
is
the
the
mode
mode
of
of
operation.
operation.
So
So
first
first
is
is
a
a
motor
motor
when
when
the
the
TEM
TEM
is
is
greater
greater
than
than
0.
0.
It
It
occurs
occurs
at
at
a
a
slip
slip
as
as
less
less
than
than
0,
0,
omega
omega
m
m
greater
greater
than
than
omega
omega
s,
m,
super
super
synchronism
synchronism
speed.
speed.
Second
Second
is
is
the
the
generator
generator
mode,
mode,
and the
and the
P
P
mechanical
mechanical
in the
in the
motor
motor
mode
mode
is
is
greater
greater
than
than
0
0
because
because
mechanical
mechanical
power
power
delivers.
delivers.
And
And
in the
in the
generator
generator
mode,
mode,
when
when
TEM
TEM
less
less
than
than
0,
0,
S
S
will be
will be
less
less
than
than
0,
0,
omega
omega
m
m
greater
greater
than
than
0,
0,
and then
then
P
P
mechanical
mechanical
is
is
less
less
than
than
0,
0,
machine
machine
receives the
receives the
mechanical
mechanical
power.
power.
In the
In the
third
third
generator
generator
mode,
mode,
when
when
TEM
TEM
less
less
than
than
0,
0, but
but S
S
is
is
greater
greater
than
than
0,
0,
and
and
omega
omega
m
m
is
is
less
less
than
than
omega
omega
s,
S,
and
and
the
the
P
P
mechanical is
mechanical is
less
less
than
than
0,
0,
where
where
machine
machine
receives the
receives the
mechanical
mechanical
power.
power.
And the
And the
fourth
fourth
mode,
mode,
which is
which is
also a
also a
motor
motor
mode,
mode,
but
but
here
here
S is
S is
less
less
than
than
0,
0,
S is
S is
greater
greater
than
than
0.
0.
Here
Here
the
the
mechanical
mechanical
power
power
is
is
greater
greater
than
than
0,
0,
so
so
machine
machine
delivers the
delivers the
mechanical
mechanical
power.
power.
And
And
in
in
this,
this,
the
the
machine
machine
receives the
receives the
power
power
via
via
stator
stator
in
in
a
a
fourth
fourth
mode,
mode,
and
and
PR,
PR,
which
which
is
is
machine
machine
delivers
delivers
power
power
via
via
rotor.
rotor.
In the
In the
generator
generator
mode,
mode,
in the
in the
generator
generator
mode,
mode,
when
when
S is
S is
greater
greater
than
than
0,
0, the
the machine
machine
delivers
delivers
power
power
via
via
stator,
stator,
but
but
it
it
receives
receives but it
receive the
receives the
power
power
via
by
rotor.
rotor.
But
But
in the
in the
generator
generator
mode,
mode, when
when
the
the TEM
TEM
is
is
less
less
than
than
0,
0,
the
the
slip
slip
is
is
less
less
than
than
0,
0,
the machine
machine
delivers
delivers
power
power
via
via
stator,
stator,
and
and
also
also
a
a
machine
machine
delivers
delivers
power
power
via
via
rotor.
rotor.
This
This
is
is
all
all
the
the
classification
classification
in the
in the
doubly fed induction
induction
generator.
generator.
Next,
Next,
a
a
PV
PV
array
array
has
has
an
an
open
open
circuit
circuit
voltage of
voltage of
420
420
volt
volt
and a
and a
short
short
circuit
circuit
of
of
32
32
ampere
ampere
and a
and a
maximum
maximum
power
power
of
of
9
9
kilowatt.
kilowatt.
Find
Find
the
the
fill
fill
factor.
factor.
Now
Now
you
you
all
all
have to
have to
calculate the
calculate the
fill
fill
factor
factor
again.
again.
These are
These are
some
some
of the
of the
additional
additional
questions
questions
which I
which I
have
have
put
put
in
in
for
for
your,
your,
you know,
you know,
uh,
uh,
practice.
practice.
So
So
calculate
calculate
this
this
and
and
write
write
down
down
the
the
answer in
answer
the
in the
chat.
chat.
Yes, yes,
Yes,
yes,
yes,
yes,
yes,
yes.
yes.
Okay.
Okay.
The
The
fill
fill
factor
factor
will
will
be
be
0.67.
0.67.
Now,
Now,
I
I
will
will
show
show
you
you
how
how
to
to
calculate the
calculate the
fill
fill
factor
factor
over here.
over here.
FF
FF
is
is
equal to
equal to
what
what
it
it
is?
is?
P
P
maximum
maximum
VOC
I
ISC.
S.
So
So
here,
here,
what
what
is
is
P?
P?
Maximum
Maximum
power
power
is
is
9,000
9,000
divided by,
divided by, okay,
9,000
9,000
divided by
divided by
VOC.
VOC.
What is
What is
VOC?
VOC?
420
420
into
into
32.
32.
If we
If we
solve it
solve it
by
by
using
using
calculator, it will
calculator, it
comes
comes
out to
out
be
to be
0.666, which
0.666,
is
which is
equal
equal
to
to
0.67,
0.67,
which is
which is 67%.
67%. Okay,
Okay.
this
This
is
is
the
the
fill
fill
factor.
factor.
Now
Now
next,
next
the
is the
PV
PV
array
array
has
has
a
a
open
open
circuit
circuit
voltage
voltage.
VOC
VOC
is
is
450
450 and a
a
short
short
circuit
circuit
current
current
of
of
30
30
ampere
ampere
and a
and a
maximum
maximum
power
power
of
of
10
10
kilowatt.
kilowatt.
Find the
Find the
fill
fill
factor.
factor.
Find the fill factor. Calculate the fill factor. Write down in a chat whatever the fill factor you got. Write down in the chat. Madhumita, Vivek, all those people, try to solve it. It will help you in your exam. Because these questions, these similar line will come in your exam. So don't try to underplay these questions. Point 074. Let me check it. So what does is this divided by? I think 10 kilowatt. Yes. 0.074. Yes, 0.074. Yes. So the fill factor comes out to be 0.074. Okay. Now, during maintenance and periods of extremely high temperatures, which equipment is used to cool down the wind turbine generator? First is the gearbox, second is the cooling system, rotor blades, and a yaw system. So the cooling system is self-explanatory actually. Cooling system helps in this. Now, to prevent the damage to the wind turbine during periods of low wind speed, which component adjusts the angle of the blades for optimum performance? First is the yaw system, second is the pitch control system, third brake system, and the generator system. Which one it is? Pitch control system. Okay. Next is to prevent the wind turbine from overloading and damaging the electrical system during high speed wind, which device is employed to limit the power output? First inverter, second cooling system, third is pitch control system, and the last one is nacelle. Okay. The first option here is the inverter. No. Inverter will do. Inverter, what it will do here? What it is? It will manage the electrical output by switching. If if the output is getting higher, it will limit it by closing of the circuits. Okay. Because whenever there is a high wind, what will happen? The output will be high. But output will be high, so there will be a large electrical energy will be produced. So that's why the inverter will do the rest of the thing. Now, these are some of the questions which I have shown to about you. So it will help you in your understanding. I assume this will help you in understanding all these the topics. So there is one topic which is left out right now. I will cover that because sometimes only teaching it will bore you out. So that's why I put the question in between. So that's why there will be some change like this. So you don't get bored. So one of the thing is here. Now we will continue the wind. Okay. So what happens here is this. One of the now I will okay.
Okay, yes. Now, wind power calculation. This is the most important thing. So, I will derive the equation of wind power calculation. Okay. So, what happened here is this. This is the swept area of the turbine blades.
These are the swept area of the turbine blades.
Okay. This is
V2 एरिया स्वेप्ट एरिया जिसको हम कहते हैं स्वेप्ट, जिसमें हवा लगती है ऐसे कहिए, इसको हम कहेंगे स्वेप्ट एरिया कहेंगे। ठीक है, तो ये एरिया क्या है? ए।
अब हमको पता है वी नो काइनेटिक एनर्जी ऑफ अ मोशन ऑफ अ विंड क्या होती है? अगर v वेलोसिटी चल रही है हाफ mv स्क्वायर, और पावर किसके बराबर होती है? d काइनेटिक एनर्जी differential of with respect to t. So if we differentiate with respect to t, here the only variable term is v. So what it will be like? 1 by 2, sorry, not v. This is the variable term, not this. So half v square dm by dt. Why dm is a variable term? Because mass is equal to, will be dependent upon the area.
Is dependent upon volume. Okay.
So higher the volume, the higher will be mass. So it will change with respect to time. So that's why dm by dt. V is a constant. So mass flow rate,
which is dm by dt
at swept area
is denoted by q. It is equal to dm by
dt. It will be equal to, because m, what is m? M is equal to
rho air density, which is in kilogram per meters cube, into area, which is in meter square, into
x,
which is the distance.
So m will be equal to what it is?
d by dt.
M is equal to rho a x. So here rho is constant,
area is constant. Only thing which is
this variable is a x. So it will be equal to rho a
dx by dt.
And we know that what is dx by dt?
It is rho a velocity of the wind.
So if we put this in the equation, it will come out to be the mass flow rate will come out to be rho a v. Now if we put this value of q, mass flow rate, in equation number 2, which is dm by dt. So what it will be like? So first equation P is equal to 1 by 2 v square
dm by dt.
And we know what is d by dt? It is mass flow rate. And it will be equal to how much?
Q, which is equal to rho
area of swept area.
A, what is it? It is the swept area. And x is the distance.
So actually, sorry, this is v.
This is velocity of wind.
So if we put this here,
it will come out to be 1 by 2 v square
dm by dt is rho
a v.
If we rearrange this,
it will come out to be vq a rho.
This is the power in the wind. Now there is a law which is known as Batts law, which we have just in question answer heard about it. Actually, he conducted an experiment in 1990, and he expresses that no wind turbine can
convert more than 16 by 27, which comes out to be 59.3% of kinetic energy into mechanical energy. So here a maximum, therefore it gives a maximum efficiency coefficient which is known as CP. What it tells here कि जो भी मैक्सिमम काइनेटिक एनर्जी होगी उसका 59.3% ही मैकेनिकल एनर्जी में कन्वर्ट हो पाएगा. So that's why this scientists give a coefficient CP max which is known as maximum power efficiency coefficient. CP max is equal to 0.59. Actually, he expresses the CP max as a what is a non-linear function. How will he expresses the CP max? CP is a non-linear function of a tip speed ratio which is generally signified by lambda and the turbine pitch angle and the turbine pitch angle and it is generally which is turbine pitch angle. It is said to be CP is equal to C1 C2 by lambda I minus C3 beta minus C4 e raised to the power minus C5 by lambda I plus C6 lambda. Now here C1 C2 C3 C4 C5 C6 are constant. Okay. And what is lambda? Lambda is the tip speed ratio. It is tip speed ratio. It is calculated by R omega by V. What is omega? It is turbine angular velocity. Omega here is turbine angular velocity. Okay. And what is R? R is the turbine radius. And okay, this is and V is the speed. So tip speed ratio. This is lambda. So and here is one thing here is also it is a beta. Beta what it is? It is the blade pitch angle. Blade pitch angle. Okay. So this is how a CP is defined by the scientist best. Okay. He calculated a value which says that the maximum power efficiency can never be greater than 59% of the kinetic energy into a mechanical energy. Now what we can finally say here is this wind power wind equation. Power wind equation. It is equal to P is equal to CP P in. It is equal to 1 by 2 CP which is dependent upon lambda and theta, rho A VI cube. Now here what happens here is this. This power will always depend upon various parameters because it depends upon these parameters, and these parameters directly depends on other parameters like first swept area. Swept area. Okay. So if the swept area increases here, the power extracted will always increases because it is directly proportional. And if it decreases, the area which is swept by the wind decreases, the power generated will also increase. Now another thing here is this: the control environmental factors. Environmental factors. Just a second. Okay. Okay. This is also dependent on the environmental factors like first air density and also on the wind speed, because our power relation is directly proportional to the cube of the wind speed. Another options are it also depends upon the tip speed ratio, which is lambda. It also depends upon the tip speed ratio. Tip speed ratio and pitch of the turbine, which is theta. Okay. This is how wind power wind equation has been developed. Now the next thing is the wind power characteristics. Means how the power varies as per the wind speed. Okay. So this is the I will draw characteristic of the wind power. So on the y-axis there will be a term known as wind power in kilowatt, and the x-axis is the wind speed. How does it vary? So what happens here is this: there are two terms. First term is the cut-in speed, after which speed increases. After a cut-in speed, power starts generating. After a cut-in speed, the power starts generating, and the rated power comes at this point. And after that, it goes off to the cut-off speed. So here, this point is the maximum power it can get. So we can say that this is the rated power. This is rated at which speed it gets the rated power. It is known as the rated speed. So after that, cut-off speed. After this speed, this is known as cut-off speed. Beyond this speed, turbine is not allowed to deliver because it may damage itself. Okay, power will not increase, but the risk of turbine damage will increase. And cut-in speed here, this is cut-in speed. Beyond this speed, there will be no power
beyond
beyond
this
this
speed.
speed.
So this is how the wind power characteristics
varies
as per the
the
wind
wind
speed.
speed.
You must, you
You
should keep in this mind.
mind.
Now,
There is another graph which tells you about the variation of
CP with
with
tip
tip
speed
speed
ratio,
ratio,
which is
which is
lambda.
How does it vary?
Okay.
So
I
I will draw you the
variation
variation like this.
On
On
the
the
y-axis
y-axis
will be
will be
the
the
parameter
parameter
CP.
CP.
It
It
will
will
vary
vary
with
with
the
the
tip
tip
speed,
speed,
which
which
is
is
represented
represented
here
here
in
in
the
the
x-axis.
x-axis.
Now,
Now,
at
now what happens here is this.
in
In
this
this,
the
the
blade
blade angle
will
will
vary.
vary.
Okay,
Okay,
like for blade
blade
angle,
angle,
what is the
what is the
blade
blade
angle
angle
here?
here?
So
Beta.
let's
Let's
say
say
beta
beta
is
is
equal
equal
to
to
0.
0.
So the
So the
variation of
variation
that
of that
CP with
CP
the
with
beta 0 will
beta
be
0 will be
like this.
like this.
Okay.
Okay.
Now
Now,
for
for
beta
beta
is equal to 2.5.
2.5.
So it
it
will
will
be
be
like
like
this.
this.
This
This
is
is
beta
beta
is
is
equal
equal
to
to
2.5.
2.5.
Now
Now,
for
for
beta
beta
is
is
equal
equal
to
to
10.
10.
Now for
Now, for
beta is
beta
equal
is
to 10. It will
it
go
will
on
go
like
down
this.
like this.
This
This
is
is
beta is
beta is
equal to
equal to
10.
10.
And this
And
is
this is
beta is
beta is
equal
equal
to
to
0.
0.
Okay.
Okay.
Now
Now,
for
for
beta
beta
is
is
equal
equal
to
to
20
20
degree.
degree.
Let's say
Let's
or
say or
15
15
degrees.
degrees.
So
So
what it will
what
be
it will be
like?
like?
It will
It
be
will be
like
like
this.
this.
Okay.
Okay.
And
And
at
at
this
this
point
point,
where
when
when beta
beta
is
is
equal
equal
to
to
0,
0,
the
the
maximum
maximum
CP
CP
will be
will be
there.
there.
I
I
forgot about it. This
this
is the
is the
maximum
maximum
CP
CP
value
value
we
we
can
can
get.
get.
It
It
is
is
around
around
0.48.
0.48.
Okay.
Okay.
As
As
you
you
can
can
see,
see,
as
as
beta
beta
increases,
increases,
the
the
CP
CPU
value,
value,
maximum
maximum
CP
CPU
value
value
gets
gets
on
on
decreasing.
decreasing.
It
It
always
always
start
start
decreasing
decreasing
over
over
here,
here,
over
over
here.
here.
And
And
that's
that's
why
why
at
at
which
which
the
the
maximum
maximum
CP
CP
gets,
gets,
we call
we
at
call
the
at
lambda
lambda
optimal.
optimal.
What
What
that
that
point
point
is
is
called?
called?
The
The
lambda
lambda
optimal.
optimal.
And
And
if
if
we,
we,
this
this
point is
point is
known as
known as
optimal
optimal
value
value
of
of
lambda,
lambda.
and
And
generally
generally
comes out
comes
to be
out to be
8.1.
8.1.
Okay.
Okay.
This is
This is
how
how
the
the
variation
variation
of
of
the
the
power
power
coefficient
coefficient
versus
versus
the
the
tip
tip
speed
speed
ratio
ratio
is
is
being
being
done.
done.
Okay.
Okay.
Now
Now,
I
I
hope
hope
this
this
is
is
clear
clear
to
to
you.
you.
Now
Now,
another
another
topic
topic
here
here
is
is
this,
this
the
the
fixed
fixed
speed
speed
turbine
turbine
generators.
generators.
Actually,
Actually,
how the
how the
energy
energy
is
is
converted
converted
in
in
a
a
wind
wind
turbine.
turbine.
So
So,
what
what
happens
happens
here
here
is
is
this.
this
There are
there are
two
two
aspects
aspects
here:
here:
mechanical
mechanical
power
power
conversion
conversion,
mechanical
mechanical
power
power
conversion
conversion,
and
and
electrical
electrical
power
power
conversion.
conversion.
Okay.
Okay.
So
So,
first is
first
the
is the
mechanical.
mechanical.
How does it?
How does it do?
So
So,
wind is wind
wind
comes
comes
over
over
here,
here,
and
and
there
there
is
is
a
a
wind
wind
turbine
turbine
rotor.
rotor. This is
wind
turbine rotor.
rotor start moving
Moving
and
and it is connected to the gearbox.
It is connected to the
the
gearbox.
gearbox.
Here power
transmission
transmission takes
takes
place.
place.
And this gearbox is connected. This gearbox is connected to a generator. And in the wind turbine case, generally DFIG are used. Here the power conversion takes place, where from mechanical to electrical. Now from here
Now, here the after from generator power it converted to electrical.
Then there comes the power electronics circuitry, power electronics circuitry and control. There are various switches over here, and after that it is fed up to the transformer, feed into the transformer, and after that it goes to the transmission and distribution.
Transmission and distribution.
This is how
energy is converted in a wind turbine. A basic layout of it.
And
And we already know that only 59.3% of the theoretical power
can
can
be
be
extracted from wind. There are 10% losses occur in drivetrain.
Okay.
10% losses occur in the generator. And we know that
and
turbine
turbine can only
convert 30 to 35% of available wind energy
energy
into
into electrical energy. Okay. This is the energy conversion.
Now,
There is another topic
where
where two types of generators are generally used.
First one is the
one
fixed
fixed
speed
speed
wind
wind
turbine
turbine
generator.
generators.
Actually,
a typical in this system, a typical fixed speed generator is employed. A rotor with a three variable blades which are controlled automatically to maintain a fixed speed rotation. Actually,
it
it
helps
helps
in
in
fixed
fixed
speed
speed
rotation
rotation
for
for
any
any
speed of
speed of it.
Generally, a rotor with three blades, where three variable pitch
pitch
blades
blades are employed in this fixed speed generators. Actually, one of the most disadvantage
of this here is
is
this:
this.
it
It
suffers
suffers
from
from
excessive
excessive
mechanical stress.
stresses.
This
This
is one of the major
major
disadvantage of
disadvantage of the
the fixed
fixed
speed
speed wind turbine generators.
That's why whenever there are high winds or gusts of the wind, they will create what? A high stress and excessive wear and tear in the gearbox. Which what will happen here is that it will lead to higher maintenance cost and the life of the wind turbine gets reduced. This is the one of the disadvantages of the fixed speed wind turbine. Now, another here in place of this there comes a variable speed wind turbine generators. These actually remove the disadvantage of fixed wind turbine as they can cope up with the windy and the gust conditions. And the electronic control system will keep the generator output, but the thing is that output will get varied. So that's why the electronic power electronic circuitry will help in stabilizing the generator output. Where what it will be? It will regulate the frequency, or it will make sure that the frequency of the generator output remains constant irrespective of the wind conditions. Okay. This is the now another type of generator has been preferred in the wind turbines, which is known as DFIG. It is known as doubly fed induction generator. Actually, it is currently most used in the wind power generating technology. Actually, what happens here is this. The basic grid connected asynchronous generator gets its excitation. One excitation is from one excitation is from the grid through the stator winding. Okay. Through stator winding, and it has a limited control over the frequency and the output voltage. But what happens here in this, another excitation has been taken through the slip rings. Which lead to a greater control over the generator output. And that's why this DFIG consists of a three-phase wound rotor generator with its stator winding, actually three-phase wound rotor generator. और इसमें क्या होता है? स्टेटर वाइंडिंग कहाँ से फेडेड है? स्टेटर वाइंडिंग are fed through grid, and the rotor is fed by a back-to-back via back-to-back converter system. Converter system in a bidirectional feedback, taking power either from the grid or from the generator. Actually, the DF, it provides, what is the advantage of this? It provides regulated power. It provides regulated power
to the grid, and it has the typical speed control range. Actually, this
generator
generator
has a
has
speed
a speed
control
control
range
range
of
of
plus
plus
minus
minus
30%
30%
of
of
synchronous speed.
synchronous speed.
Now,
Now,
what
what
happens
happens
here
here
is
is
this.
this.
Another
Another
thing
thing
is
is
that
that
it
it
can
can
produce
produce
twice
twice
the
the
power.
power.
One of
One
the
of the
major
major
advantage of
advantages of
DFIG is
DFIG is
it
it
can
can
produce
produce
twice
twice
the
the
power
power
of a
of a
similar
similar
size
size
of a similar
similar
size
size
single
single
fed
fed
machine.
machine.
Single
Single
fed
fed
machine
machine
while
while
incurring
incurring
same
same
losses.
losses.
Okay,
Okay,
that's
that's
why
why
the
the
efficiency
efficiency
of
of
DFIG
DFIG
doubly fed
double fed
induction
induction
generator
generator
is
is
much
much
greater
greater
than
than
single fed.
single fed.
And
And
due to
due
this
to this
reason,
reason,
they
they
are
are
being
being
used in
used
the
in the
wind
wind
turbine
turbine
because
because
in the
in the
wind
wind
turbine
turbine
already
already
around
around
40% of
40% of
energy
energy
has
has
been
been
lost from
lost
the
from
wind
the wind
because we
we
already
already
seen
seen
according
according
to
to
the
the
bets
bets
that
that
wind
wind
power
power
only
only
59.3%
59.3%
can be
can be
transferred.
transferred.
So
So it is our
it
it
is
is
our
our
main
main
aim
aim
to
to
implement
implement
or
और
we
we
can
can
say
say
कि
कि
ऐसा
ऐसा
सिस्टम
सिस्टम
बनाएं
बनाएं
कि
कि
जहाँ
जहाँ
पे
पे
अब
अब
हमारी
हमारी
जो
जो
बची हुई पावर है
बची
वो
वो
ज़्यादा
ज़्यादा
लॉस
लॉस
ना
ना
हो.
हो.
तो
तो
that's
that's
why
why
doubly
doubly
fed
fed
induction
induction
generators
generators
has
has
been
been
used.
used.
Okay.
Okay.
Now
Now
what
what
happens
happens
here
here
is
is
this.
this:
There are
there are
four
four
modes
modes
of
of
operation
operation
which I
which I
have
have
shown in
shown in
the
the
question,
question,
but
but
I
I
will
will
write
write
it
it
down
down
over
over
here
here
again.
again.
First is
First
the
is the
motor.
motor.
When
When
TE
TE
greater
greater
than
than
TEM
T
greater
greater
than
than
0
0
and
and
slip
slip
is less
is
than
less than
0.
0.
At
At
this
this
point,
point,
omega
omega
m
m
is
is
greater than
greater than
omega
omega
s.
s.
So
So
here
here
what
what
happens
happens
here is
here
this:
is this:
mechanical
mechanical
power is
power is
0.
0.
What
What
does it
does it
mean?
mean?
Machine
Machine
will
will
deliver
deliver
the
the
mechanical
mechanical
power.
power.
But
But
stator
stator
power
power
TS
TS
is
is
also greater
also
than
greater
0.
than 0.
So
So
machine
machine
receives
receives
power
power
via
via
stator,
stator,
and
and
PR
PR
is
is
also
also
greater than
greater than
0.
0.
It
It
says
says
machine
machine
receives
receives
power
power
via
via
rotor.
rotor.
Now, in
Now,
the
in the
second
second
mode,
mode,
when a generator mode is
generator
done,
mode is
TEM
TM
gets 0
is
less
less
than
than
0.
0.
Slip
Slip
is
is
less
less
than
than
0.
0.
But omega m,
Omega
if
m, if
omega
omega
m
m
is
is
greater
greater
than
than
omega
omega
s,
s,
which
which
is
is
known as
known
a
as a
super
super
synchronous
synchronism
speed,
speed,
the
the
mechanical
mechanical
power
power
will be
will be
less
less
than
than
0.
0.
It
It
means
means
machines
machines
receive
receive
mechanical
mechanical
power,
power,
and
and
PS
PS
will
will
all
all
will
will
greater than
greater than
0,
0,
and
and
PR
PR
will is
is
also
also
greater
greater
than
than
0.
0.
Sorry,
Sorry,
less
less
than
than
0.
0.
Now,
Now,
another
another
mode
mode
is the
is the
generator
generator
mode.
mode.
Generator
Generator
mode
mode,
where
where
TEM
TEM
is
is
less
less
than
than
0.
0.
But
But
here,
here,
what
what
happens
happens
here is
here is
this:
this:
S
S
is
is
greater than
greater
0.
than 0.
So
So
omega
omega
m
m
is
is
less
less
than
than
omega
omega
s.
s.
This is
This is
known
known
as
as
sub
sub
synchronous
synchronous
speed.
speed.
At
At
this
this
point, the
point, the
mechanical
mechanical
power
power
is
is
less
less
than
than
0,
0,
which
which
means the
means the
mechanical
mechanical
machine will
machine will
receive the
receive the
power,
power,
mechanical
mechanical
power,
power,
and
and
PS
PS
is
is
less than
less
0,
than 0,
which
which
means the
means
machine
machine
will
will
deliver
deliver
the
the
power
power
via
via
stator,
stator,
and
and
PR
PR
is
is
greater
greater
than 0,
than 0,
which
which
means
means
machine
machine
will
will
receive the
receive the
power
power
via
via
rotor.
rotor.
Another
Another
mode is
mode is
here,
here,
which is
which is
motor.
motor.
At
At
this
this
point,
point,
motor
motor
TEM
TEM
is
is
greater than
greater
0.
than 0.
Now, what
What
happens
happens
here is
here is
this:
this:
at S
as
greater
greater
than
than
0,
0,
omega
omega
is
is
less
less
than
than
omega
omega
m is
m is
less
less
than
than
omega
omega
s.
s.
This is
This
a
is a
sub-synchronous
sub-synchronism
speed.
speed.
At
At
this
this
point,
point,
P
P
mechanical
mechanical
will be
will be
greater
greater
than
than
0,
0,
which
which
means
means
machine
machine
will
will
deliver
deliver
mechanical
mechanical
power,
power,
and
and
PS is
PS is
greater
greater
than
than
0.
0.
It
It
means the
means the
machine
machine
will
will
receive
receive
power
power
via
via
stator,
stator,
via
via
stator,
stator,
and
and
for
for
PR
PR
will
will
be
be
less
less
than
than
0.
0.
At
At
this
this
point,
point,
it will
it will
deliver
deliver
power
power
via
via
rotor.
rotor.
This is these are a detailed actually this is a detailed mode of operation of a doubly fed induction generator. If
If
you
you
have
have
any
any
question,
question,
you
you
can
can
ask
ask
right
right
now.
now.
Okay.
Okay.
I
I
don't
don't
think
think
anyone
anyone
have a
have a
question.
question.
Okay.
Okay.
There
There
is,
is,
do you
do you
guys
guys
know
know
about
about
the
the
India's
India's
target
target
of
of
achieving
achieving
175
175
gigawatt of
gigawatt of
energy
energy
by
by
2022?
2022?
This
This
has
has
been,
been
in
in
which
which
60
60
gigawatt has to
gigawatt
be
has to
come
be come
from the
from the
wind
wind
power.
power.
Okay,
Okay,
this
this
is
is
one of
one
the
of the
India's,
India's
you know,
you know
achievement.
achievement.
Now,
Now,
and there
and there
is
is
some
some
data
data
which
which
shows
shows
that
that
uh,
uh,
till
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 2017
2017
till
till
2017
2017
the
the
wind
wind
power
power
wind
wind
power in
power
a
in a
grid
grid
interactive mode
interactive
in a
mode
grid
in a grid
interactive mode.
interactive mode.
Wind
Wind
power
power
has
has
been
been
installed
installed
to
to
951.1
951.1
this
this
much
much
in
in
megawatt,
megawatt.
and
And
in
in
an
an
off-grid
off-grid
position
position,
wind
wind
powers
powers
has
has
been
been
installed.
installed.
I will
I'll
give
give
you
you
an
an
answer.
answer.
uh,
In
in an
an
off-grid
off-grid
capacitive
capacitive
mode,
mode,
where
where
other
other
renewable
renewable
energies
energies
has
has
been
been
done,
done,
like
like
there
there
are
are
captive
captive
power
power
plants
plants
in
in
off-grid.
off-grid.
This
This
total has
total
comes
has
to
comes
around
to around
1463.98
1463.98
megawatt
megawatt
equivalent.
equivalent.
Okay,
Okay,
in an
in an
off-grid,
off-grid
in an
in an
off-grid
off-grid
manner.
manner.
Okay,
Okay,
this
this
is
is
some,
some
Indian.
Indian.
This
This
data is
data is
from
from
MNRE,
MNRE,
the
the
Ministry
Ministry
of
of
New
New
and
and
Renewable
Renewable
Energy.
Energy Sources.
Okay,
Okay,
I
I
hope
hope
you
you
have,
have
learned
learned
something
something
from
from
this
this
session.
session.
If you
If
have
you have
any
any
question, you
question, you
can
can
ask me
ask me
right
right
now.
now.
There
There
are,
are
I
I
let's
let's
see,
see,
there
there
are
are
various
various
farms
farms
in
in
wind
wind
farms in
farms in
India,
India,
like
like
wind
wind
farms
farms
in
in
India.
India.
First one, the
First, the
largest
largest
one
one
is
is
in
in
Tamil
Tamil
Nadu.
Nadu.
That
That
name is
is
Mopaddal,
Paddal,
Mopandal wind farm, and it
and it
has the
has the
capacity of
capacity of
around
around
1500
1500
megawatt.
megawatt.
Second
Second
one
one
is,
is
it is
it is
actually,
actually
second
second
one is
one is
in
in
Rajasthan,
Rajasthan,
which has
which
been
has been
developed by
developed
the
by the
Suzlon
Suzlon
Energy.
Energy.
It is
It is
in
in
Jaisalmer.
Jaisalmer.
It is
It is
around
around
1280
1280
megawatt,
megawatt,
something like
something
this.
like this.
Okay,
Okay,
third
third
one,
one,
there
there
are
are
another
another
one
one
here
here
in
in
Maharashtra,
Maharashtra,
which
which
is
is
Brahmaneval
Naval
wind
wind
farm,
farm,
which
which
is
is
around
around
530
530
megawatt.
megawatt.
Okay,
Okay,
there
there
is
is
another
another
one
one
which
which
has
has
been
been
developed by
developed by
Suzlon
Suzlon
Energy in
Energy in
Maharashtra,
Maharashtra,
which is
which is
known as
known as
Chakala
Chakala
wind
wind
farm.
farm.
It's,
It's
its
its
capacity
capacity
around
around
220
220
megawatt,
megawatts,
something like
something
this.
like
Okay,
this. Okay,
this
this
is,
is
so
so
there
there
are
are found
wind
wind
farms
farms
installed in
installed in
India,
India,
and
and
government
government
has,
has
given
given
large
large
in
in
subsidies
subsidies
to
to
the
the
people who
people who
are,
are
installing
installing
these
these
wind
wind
farm,
farm,
so
so
that,
that
the
the
wind
wind
energy
energy
can
can
be,
be
will be
will be
installed in
installed in
India.
India.
And
And
reasons
reasons why
why wind
wind
energy has
energy has
been
been
promoted.
promoted.
The
The
one of
one
the
of the
reason
reason
is,
is
I
I
already
already
told you
told you
about, this
about
is a
is a
clean
clean
zero
zero
emission.
emission.
There is,
There is
as you
as
have,
you have
I
I
have
have
told you
told you
about the
about the
power
power
generation,
generation,
all
all
these
these
things.
things.
You have
You have
seen
seen
there
there
is
is
nothing,
nothing,
कोई
कोई
ऐसी
ऐसी
चीज नहीं
चीज
है
नहीं है
जहाँ
जहाँ
से
से
इमिशंस
इमिशंस
निकल रहे
निकल
हो,
रहे हो,
कहीं से
कहीं से
कोई
कोई
NO2
NO2
निकल रही
निकल
हो,
रही हो,
SOX
SOX
को
की
कोई
कोई
कंपाउंड
कंपाउंड
निकल रही
निकल
हो,
रही हो,
कार्बन
कार्बन
डाइऑक्साइड
डाइऑक्साइड,
कोई
कोई
चीज नहीं
चीज
निकल
निकल
रही
रही
है।
है।
एयर
एयर
क्वालिटी
क्वालिटी
बेहतरीन
बेहतरीन
रहती है, एयर
रहती है, एयर
क्वालिटी पे
क्वालिटी
कोई
पे कोई
इफेक्ट नहीं
इफेक्ट
है।
नहीं है।
और
और
इसका
इसका
सबसे
सबसे
मेन
मेन
रीजन क्या
रीजन
है
क्या
कि
है
जो
कि जो
हमारी
हमारी
डिपेंडेंस है
डिपेंडेंस है
फॉसिल
फॉसिल
फ्यूल्स पे,
फ्यूल्स पे
वो भी
reduce
reduce हो
हो
रही है.
रही है.
So
So
that's
that's
why
why
wind
wind
energy and
energy,
solar
solar
energy,
energy,
solar
solar
and
and
wind,
wind,
these
these
both
both
two energies
energies
are
are
very
very
much
much
promoted
promoted
by
by
worldwide,
worldwide,
not
not
only in
only in
India
India
but
but
worldwide.
worldwide.
तो
तो
इससे
इससे
क्या
क्या
होता
होता
है कि
है कि
हमारी
हमारी
डिपेंडेंस जो है
डिपेंडेंस
फॉसिल
फॉसिल
फ्यूल से
फ्यूल
वो
वो
रिड्यूस हो जाती
रिड्यूस हो
है.
जाती है.
और
और
हमको
हमको
जो
जो
है
है
ये
ये
कि
कि
जो
जो
ऑयल
ऑयल
इंपोर्ट
इम्पोर्ट
होता
होता
है, जो
है, जो
एनर्जी
एनर्जी
इंपोर्ट होता है,
इम्पोर्ट
वो
होता है,
कम करना
वो कम
पड़ता है.
करना होता है.
तो
तो
हमारा जो है
हमारा जो
ना
है ना
डोमेस्टिक
डोमेस्टिक
और
और
नेशनल
नेशनल
सिक्योरिटी के
सिक्योरिटी के
पर्सपेक्टिव से
पर्सपेक्टिव से
वी गेट
वी
मोर
गेट मोर
सिक्योर
सिक्योर
अबाउट.
अबाउट.
ओके.
ओके.
लेकिन
लेकिन
इट
इट
हैज
हैज
आल्सो
ऑल्सो
इफेक्ट.
इफेक्ट.
तो
सो
लेट्स
लेट्स
टॉक
टॉक
अबाउट द
अबाउट द
इफेक्ट.
इफेक्ट.
इफेक्ट क्या
इफेक्ट
है,
क्या है,
नेगेटिव इफेक्ट्स
नेगेटिव
क्या
इफेक्ट्स क्या
है?
है,
इफेक्ट्स
इफेक्ट्स
ऑफ
ऑफ
सोलर
सोलर
प्लस
प्लस
विंड.
विंड.
आई विल
आई विल
टॉक अबाउट
टॉक
बोथ.
अबाउट बोथ.
सोलर का
सोलर का
सबसे बड़ा
सबसे
इफेक्ट
बड़ा
क्या है
इफेक्ट क्या है
कि
कि
जो भी
जो भी
वेस्ट होता है
वेस्ट होता है
सोलर
सोलर
वेस्ट,
वेस्ट,
देयर
देयर
इज
इज
नो
नो
रिसर्च
रिसर्च
वाइज
वाइज
प्रॉपर
प्रॉपर
डिस्पोजल नहीं,
डिस्पोजल नहीं,
प्रॉपर
प्रॉपर
डिस्पोजल नहीं.
डिस्पोजल नहीं.
ओके.
ओके.
क्योंकि
क्योंकि
अभी
अभी
टेक्नोलॉजी इतनी
टेक्नोलॉजी इतनी
एडवांस नहीं
एडवांस
हुई
नहीं
कि जो
हुई,
सोलर
सोलर
वेस्ट
वेस्ट
होते हैं, जो
होते हैं, जो
पैनल्स
पैनल्स
जो एक
जो एक
बार
बार
लाइफ
लाइफ
एक्सपेक्टेंसी
एक्सपेक्टेंसी
अपनी
अपनी
पूरी
पूरी
कर
कर
लेते
लेते
हैं,
हैं,
व्हाट
व्हाट
शुड बी
शुड
यूज
बी
देम.
यूज.
देयर आर
देयर आर
सम
सम
ऑफ
ऑफ
कुछ
कुछ
थोड़ा
थोड़ा
बहुत
बहुत
यूजेज हो
यूजेज हो
रहा
रहा
है,
है,
लेकिन
लेकिन
इंडस्ट्रियल
इंडस्ट्रियल
स्केल पे
स्केल पे
देयर इज
देयर इज
नथिंग
नथिंग
गोइंग ऑन.
गोइंग ऑन.
ओके.
ओके.
विंड का
विंड
क्या
का
है?
क्या है,
विंड
विंड
जिस
जिस
जगह
जगह
लगती
लगती
है
है
तो
तो
एक्चुअली
एक्चुअली
इट
इट
क्रिएट लॉट
क्रिएट
ऑफ
लॉट ऑफ
नॉइस.
नॉइस.
द विंड
द विंड
टर्बाइन
टर्बाइन
जब वो
जब
मूव करती
मूव
हैं
करती है
इट
इट
क्रिएट
क्रिएट
नॉइस.
नॉइस.
तो
तो
इसीलिए
इसीलिए
ह्यूमन
ह्यूमन
पॉपुलेशन
पॉपुलेशन
का
का
सरवाइव
सर्वाइव
करना
करना
इसके अराउंड थोड़ा
क्या
मुश्किल
मुश्किल
रहता है.
रहता है.
और
और
प्लस
प्लस
इट
इट
आल्सो
also
हैज
has some
समटाइम
time
द
the
टर्बाइंस
turbines
गेट
get
ब्रेक
break
डाउन.
down.
इन
In
एनी
any
केस
case
इट
it
विल
will
वो
वो
ह्यूमन
human
पॉपुलेशन
population
पे
पे
गिरेगा.
गिरेगा,
तो
तो
इट
it
विल
will
हैव
have a
लाइफ
life
डेंजर्स भी होते
dangerous भी
हैं
होते
अगर
हैं
हम
अगर
नियर
नियर
बाई
बाई
विंड
विंड
फार्म्स
फॉर्म्स
के
के
रहें
रहें
तो.
तो.
और
और
सब ऑफ
some
द
of the
थिंग,
thing
अनदर
another
थिंग इज
thing is
देयर
there
वाइल्ड लाइफ
wildlife
इम्पैक्ट बहुत
impact
ज्यादा
होता
है.
है.
व्हाई?
Why?
बिकॉज
Because
इसके
इसके
लिए
लिए
हमको एक
हमको एक
क्लियर
क्लियर
एक
एक
एक एम्प्टी
एम्प्टी
मैदान
मैदान
चाहिए
चाहिए
होगा,
होगा,
एक
एक
बहुत
बहुत
बड़ा
बड़ा
एरिया
एरिया
चाहिए
चाहिए
होगा.
होगा.
देयर
देयर
शुड
शुड
नॉट नो
नो
वाइल्ड
वाइल्ड
लाइफ.
लाइफ.
बिकॉज
बिकॉज
अगर
अगर
वाइल्ड
वाइल्ड
लाइफ
लाइफ
होगी
होगी
तो
तो
हवा
हवा
विंड
विंड
एनर्जी
एनर्जी
प्रॉपरली
प्रॉपरली
हमको मिल
हमको
नहीं
मिल नहीं
पाएगी.
पाएगी.
उसका
उसका
एक्सट्रैक्ट
एक्सट्रैक्ट
विंड से
विंड से
पावर
पावर
नहीं
नहीं
कर
कर
पाएंगे
पाएंगे
ड्यू
ड्यू
टू
टू
वाइल्ड
वाइल्ड
लाइफ
लाइफ
की
की
वजह
वजह
से,
से,
फॉरेस्ट
फॉरेस्ट
की
की
होने
होने
की
की
वजह
वजह
से.
से.
अनदर
Another
थिंग
thing
इज
is
दैट
that
इट
it
विल
will
यूज
use
अ
a
लार्ज
large
एरिया.
area.
ओके.
Okay.
और ये
और ये
हमको
हमको
पता है
पता है
कि
कि
हैबिटेंट
हैबिटेंट
एरिया जो है
एरिया जो है
ह्यूमंस के
ह्यूमंस के
लिए
लिए
काफी लेस है.
काफी लेस है.
तो
So
दैट्स
that's
व्हाई
why
इट इज
it is
वेरी
very
मच
much,
इट
it
विल
will
क्रिएट
create
इट विल इंक्रीज द प्रॉपर्टी
property
वैल्यूज.
values.
व्हाई?
Why?
बिकॉज
Because
बहुत
बहुत
बड़ा
बड़ा
एरिया तो
एरिया तो
यही
यही
हम
हम
यही जो है
यही
विंड फार्म्स ही
farms ही
एक्वायर कर
एक्वायर कर
लेंगे.
लेंगे.
तो
तो
अगर
अगर
हमारे पास
हमारे पास
ज्यादा
ज़्यादा
विंड
विंड
फार्म्स
फार्म्स
होते हैं,
होते हैं, राइट,
अगर
अगर
हम
हम
बहुत
बहुत
ज्यादा
ज़्यादा
बढ़ाते
बढ़ाते
हैं,
हैं
तो
तो
फिर
फिर
हैबिटेंट ह्यूमंस के
ह्यूमंस
लिए
के लिए
रहने के
रहने
लिए
के लिए
कम
कम
रहेगी
रहेगी
जगह.
जगह.
तो
तो
इसी
इसी
वजह से
वजह से
प्रॉपर्टी
प्रॉपर्टी
वैल्यूज
वैल्यूज
भी
भी
इंक्रीज
इंक्रीज
करे
करे
जाते
जाते
हैं.
हैं.
और
और
सबसे
सबसे
बड़ा
बड़ा
इंपॉर्टेंट
इम्पोर्टेंट
एस्पेक्ट
एस्पेक्ट
क्या
क्या
है
है
कि
कि
ट्रांसपोर्टेशन
ट्रांसपोर्टेशन
ऑफ द
ऑफ द
ब्लेड्स,
ब्लेड्स,
बिकॉज
बिकॉज
दीज
दीज
ब्लेड्स
ब्लेड्स
आर
आर
वेरी
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 ह्यूज.
ह्यूज.
तो
So
ट्रांसपोर्टेशन इज
transportation is
आल्सो अ
also a
नेगेटिव
negative
एस्पेक्ट.
aspect.
हाउ
How
कैन वी
can we
ट्रांसपोर्ट
transport
देम?
them?
So
So
these
these
are
are
all
all,
the
the
negative
negative
effects.
effects.
Till now
Till
we
now
have
we have
studied
studied
all the
all the
positive,
positive,
ये renewable
renewable
fossil
fossil
fuel
fuel
dependence
dependence
होती है,
होती
ये
है, ये
कम हो
कम हो
जाता है,
जाता है,
वेस्ट भी
वेस्ट भी
जनरेट
जनरेट
करता
करता है
है विंड.
विंड.
ठीक
ठीक है.
है. तो
तो
ये
ये
सब
सब
चीजों को
चीज़ों
भी
को भी
देखना
देखना
होगा.
होगा.
These are
These are
some of
some
the
of the
negative
negative
effects,
effects,
and you
and you
should
should
keep
keep
these
these
in
in
mind,
mind,
because
because
nowadays
nowadays
whenever
whenever
you
you
go
go
for
for
any
any
interview,
interview,
people know
know
about the
about the
positive
positive
aspect,
aspect,
but they
but they
need to
need
know
to know
whether
whether
the
the
candidate
candidate
should
should
have
have
any
any
idea
idea
about the
about the
negative
negative
aspect,
aspect,
because
because
every
every
technology
technology
comes,
comes,
it
it
comes
comes
with
with
positive and
and
negative.
negative.
So
So
what
what
our aim
should be
as
as
a
a researcher
or
or
a
a engineering student,
we
we
should
should
minimize
minimize
the
the
risk
risk
so
so
that
that
we
we
can
can
we
we
can
can
have
have
a positive
पॉजिटिव
impact
इम्पैक्ट
उसके
उसके
ज़्यादा
ज़्यादा
हम
हम
इस्तेमाल
इस्तेमाल
कर
कर
पाएं.
पाए.
So
Okay,
okay, let's
let's
wrap
wrap
up
up
this
this
session.
session.
We
We
will
will
meet
meet
again
again
in
in
next
next
Tuesday,
Tuesday,
and we
and we
will
will
try
try
to
to
cover
cover
other
other
aspect of
aspect of
this.
this.
If you
If
have
you
any
have any
question,
question,
you
you
can
can
ask me
ask me
right now,
right now
or
or
write me
write
in
me
the
in the
chat.
chat.
Okay,
Okay.
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 Let's
Let's
wrap up
wrap
this
up this
session.
session.
Thank you
Thank
for
you for
coming
coming
here.
here.
We will
We will
meet
meet
next
next
week
week
also.
also.